Hi, I'm putting out this video because a few students had asked me if they could get a video made regarding this 2D vector coding activity. So I believe you all have access to this Google Doc. So I'm just going to go to this link and start from scratch here. I'm going to go to GlowScript. Here is the code that has been already written. Just going to run it here. There it is loading, and there's a grid in the background. I click once, I get the blue vector here. This is the origin, by the way. Click another time, this is the red vector that's showing up. And that's it. We have two vectors. And so this activity, we're asked to basically add some lines of code, draw in a resultant vector, get those vectors to be drawn head to tail, and find out the length of the vector and find out the angle. So let's go ahead and do that. So if I view the program, the first thing I'm going to ask you to do is actually copy this code and go into your own code itself. All right, so I'm just going to make a new program in here. All right, and I'll just create a program called Vectors. Okay, and so in here, I have my code. Okay, should run it again just to make sure it all works properly here. There it is. And we have vector A here and vector B, which is in red. Okay, this bit here where it says make grid is just creating a function that is calling up actually a function called make grid, and that function is defined down here. I have to admit that I did not write this. I stole that from somewhere else. I think from the Let's Code Physics webpage video, and I think it's really great. It basically makes the horizontal and vertical lines that you have in that grid that is nicely spaced out. What we're really concerned with is actually these lines of code right here between line 7 to 11. In line 7, just to point that out, line 7 and line 9 and line 11, they are basically just lines that are pausing the program until the user clicks on the keyboard or clicks on the mouse, and then it progresses to the next line. So it'll pause the program and won't move on to line 8, for example, until the user has clicked. Okay? Line 8 is producing that first arrow. So let's talk a little bit about that. Now you want to learn maybe a little bit about arrows. So if I go over to, I guess, type in arrow and GlowScript, just Google that. Your first hit will probably be the help web page to GlowScript here. And it shows you a little bit about arrows. So you can see that arrows created here. The position, the tail of that arrow is where the position is. So you can see in here it's located at 0 on the X, and then 2 up vertically, and then 1 into the Z, or out of the Z. You can see this XY coordinate. The axis is showing where that head of that tail points. So it's going to define really the direction and the magnitude of your vector. So it has 5 units to the right and nothing along the X or Y, the Z and Y axes. So you can see it's 5 units to the right. Okay, there's also shaft width, which is just affecting the size of that shaft width, the head and the shaft. There's a few other attributes, but let's not worry about that. We'll just use the code that's the way it's written. Okay, so we have the first arrow, A, is at 3, 0, 0. And then the next one has an axis that's going up 4 units. So you can see the one is going horizontally to the right, 3 units, and the other one is going vertically up 4 units. But the problem is when you run this program right now, these two vectors are what we call concurrent vectors. Their tails are attached to each other. So I would like to transplant this red arrow so that its tail is at the tip of the blue arrow. So how do we do that? So in class, or at least most of my classes, I had you guys figure that out on your own. You may want to pause the video, see it, try it yourself. Okay, so one of the ways that you might have done it is realize that you need to reposition the position of the tail of vector B. So you can realize hopefully that its tail needs to be at the tip of arrow A. So you might change that to be 3, 0, 0. So let's see, I'm going to shift the tail of B, so now it's 3 units to the right. So if I run the program, there's the blue arrow, now the red arrow is attached. Now we have tip to tail. Okay? Now, as a good coder, you might find it better if you embed it so that, let's say you make a change. For example, let's say I change A arrow to be 4 units and I run it, then you'll see that now the red arrow has not been transplanted to the right place because it's based on the old location of my first vector. So what we might want to do is instead of using numbers in here, I would recommend that you set the position of B's arrow at A dot axes. So it calls up object A and the attribute of the axes, which in this case would be vec3, 0, 0. Okay, so that's a bit better because then I make only one change at the beginning, and then suddenly it always works in the next lines. I don't have to go all the way through my program. That would be a good coding skills here. So let's say if I change this, say, to 3, 4, and then make this like -1, 4, and I run it, and you can see that there's the first vector, and the next vector is always going to be placed at the tip of that first vector. Okay, so going back to our original notation of it being 3 units to the right and then 4 units up, now let's move on to making the resultant vector here. So we need to draw a resultant vector of that program here. So we're going to add another vector, which I'll call R. Okay, and I'm just going to, because I don't want to type all this stuff, I'm going to copy all this code here, but make some changes. So I'm going to make that arrow be green. Okay, that's my resultant vector. Now, I know that actually the resultant needs to be starting at 0, 0. So vec 0, 0, 0. Okay, so if I, and then it has to go to the very end of those two vectors. So right now, if I run it, the axis is not correct on it. There's the first, there's the second, and then there's my resultant. My resultant's tip is not ending over here. It should go along the hypotenuse of my triangle. So where would that green arrow have to be? Well, hopefully you can see it's 1, 2, 3 units to the right and 4 units up. All right, so what I need to do is change that axis so it's 3, 4. And you might notice I'm really adding the x components. 3 and 0 gives you 3, 0 and 4 gives you 4, and 0 and 0 give you 0. So now when I run it, okay, we can see the first vector, second vector, and the third vector. Now, of course, I'm doing this numerically, not the greatest, because let's say I've changed this again to say 3, 4, and then I don't know, -1, 4. Run this. Now I have a different, say, vector. Here's the first one. There's the second one. But obviously my result is not working out. It's going back to what it was before. So how do I fix it so that it always works? I really need to erase this, right? And we need to make it so that what you're really doing is adding these, like 3 minus 1, which would give you 2, and 4 and 4 gives you 8. So I guess we could put that in. That's, 3 minus 1, that's 2, and then this is 8, and then 0. And so I could run it, and this should work now. But that's just a numerical solution, right? How can you make it work all the time? It'd be better if I don't have to sit there and add this by myself. So you can. If you erase this, do something similar. Really what we were doing is we were adding these vectors together. We were adding the 3 and the -1, the 4 and the 4, and the 0 and 0. So really you're taking A dot axes plus B dot axes. When you do that, you're adding these two vectors together. So that when I run it now, okay, you can see there's the first vector, there's the second vector, and now the third vector is automatically adding them up together. Okay, I'm going through this really quickly so I can make this video not so long. All right, let's see what else I need to do in this coding activity. We also needed to print the length of the vector. So how do we do that? Let's maybe make it go back to being rather simple. 3, 0, and 4 along the y-axis. So you can see, hopefully when you run this, you can see that's 3, 4, and then this should be actually 5. It's a 3, 4, 5 triangle. All right? But how can you compute it? Let the computer do all the work, right? So let's add in a line. Print statement, the magnitude of the resultant is, close quotes, and then how do you do that? Well, one way you might realize is, I suppose you could just say it's 5, but then you have to do that by yourself, right? Let's let the computer do the work for you, right? You could probably do square root, right? And then you're going to square root the x component of the axis, like r dot axis, and then square it. And then you can do r dot axis dot, we got to do along the x-axis, and r dot axis dot y, and then square that. And then I guess we could do z2, but that won't make a difference because they're both 0. But we'll go ahead. This is really just the distance formula, right? So if I run this, hopefully we'll get a statement here at the bottom. Yep, there it is, 5, and it's computing it. But there is other ways of doing it. There are, if you kind of go back and Google maybe on GlowScript and type in, I don't know, magnitude of the vector. You might find, oh, vector object and find some kind of help. Oh, yeah, there is. This mag, parentheses, A will find the magnitude, or A dot mag. So that's another way to quickly do what I had just written in the code. So I could, I suppose, erase all of this and just say the mag of R. Let's see if that works. R, oh, what part of R? I'm not sure if it's, maybe, let's see. Because R is an object, so maybe that's not going to work. It's undefined because I have to take the magnitude of what? The magnitude of the axes vector. Because I didn't know which attribute. Is it the position? Is it the axes? Let's see if that works. So the magnitude of the axes. Aha. Yeah. Alternatively, I think another way you can do it is, I think there is glow script. You can try that. Check this out. Length. Right? And I believe there is like, I can't find it in here, but another way I remember doing it is you could actually type in r dot length. And I believe that works too in getting the magnitude of it as well. All right, what else? What else? What else are we asked to find out? We are asked to find the angle that it makes relative to the resultant. So again, just running the code, what angle are we referring to? We are referring to this angle that's in here. So I want to write a statement to figure out that angle. Okay, hopefully you realize, let's say we know this side is 3 and this side is 4, we can use the arctan, right, tan inverse of 4 over 3. Well, this side here is the resultant along the y-axis, and this is the resultant along the x-axis. So we need to take the arctan of that. So let's write a statement in here. Print, all right, the angle relative to the horizontal is, and we're going to do a tan r axis dot y divided by r dot axis dot x. Okay, and we run it. But you may notice that number is not what you're used to seeing, right? Usually we report angles in degrees. Remember, computers think in radians. So we actually need to convert this to degrees. All right, so maybe I want to put a little sign and say degrees. Okay, and so we're going to convert this to degrees. One way you could do it would be to multiply by 180 and divide by pi. Pi is already built into it. Remember, there are 180 degrees and 1 pi radians, or pi radians, right? So if I run it here, aha, 53. Now you could round that to the nearest one if you would like. You could like put round and round that whole expression. And so that, oops, no, I lost that. Yeah, round and then run it. Okay, and now I have it round to the nearest 53 degrees. Okay, so hopefully that's helpful in getting part 1. We drew the vectors in. We found the resultant vector at the length of it, the angle of it.